So because 5 pi over 6 is a special angle, we were able to get exact values for this. And so I believe radius 7, angle 5 pi over 6 is the same as rectangular, x equals negative square root of 3 over 2, y equals 7 halves. And I just want to confirm that. And GeoGebra is a good place to check points. So I'm just going to bring up a new GeoGebra window. I'm just going to use their graphing calculator. And I don't want to recover. Okay, so here I am in rectangular coordinates. I could ask GeoGebra in the settings here to change the grid to, I think it's here, polar. And so then it switches. And so these are pi over 6, pi over 3, pi over 2. It doesn't show pi over 4 here, but I'm sure I could force it to if I played with the settings. And so first I just want to check out that polar point I had, which was 7, 5 pi over 6. And in GeoGebra, you have to put a semicolon to tell it to do polar. So 7, semicolon, 5 pi over 6. And so there's that point right here, like I had sketched. And I believe that's the same as a certain XY point. And so to do an XY point, I just use a comma with parentheses. So parentheses, negative 7 square root of 3 over 2. And then the y value is just 7 halves. So comma, 7 halves. And if I hit enter, that point B should sit just on top of point A here. So I'm going to turn it off. Point B is gone. Point B is on. And you can see, yep, those two are the same point. Rectangular version versus the polar version. So that's one thing GeoGebra does easy. Rectangular points and polar points. Functions, again, I mentioned earlier, are a little more difficult in any program.